Welcome back. Now we return to our original problem. We want to consider the solid obtained by rotating the region between the curve y equals 3x squared minus 6x cubed and y equals 0 about the y-axis. So y equals 3x squared minus 6x cubed is this curve. Y equals 0 is the x-axis, and you want to rotate this region about the y-axis. So let me remind you, volume of a cylindrical shell or a thickened cylinder, right, is 2 pi r h delta r. So that tells me delta r. Okay, all right. Now we get when I rotate this region about the y-axis, we get a region, solid region like that. Okay. Now you notice you get a thickened cylinder here for each r going from 0 to 0.5. Each cylindrical shell has thickness delta r. The radius r, thus the radius r, lies in the interval 0 to 0.5. So if r is small, you have a small cylindrical shell. So as r increases, you have varying cylindrical shells. For each r, the height. What is the height? Well, height is given by this point, that is the y-coordinate. Y-coordinate is 3x squared minus 6x cubed. So what should I substitute for x? Well, that's my x-coordinate. Radius is my x-coordinate. So the height is 3r squared minus 6r cubed. All right. So for each r, the cylindrical shell has volume 2 pi r 3r squared minus 6r cubed delta r. So the volume of the entire solid, it's going to be a Riemann sum, limit of the Riemann sums and so on and so forth, which tells me it's an integration. Delta r becomes dr. The limits are 0 to 0.5, 2 pi r 3r squared minus 6r cubed, which tells me I get the 2 pi outside and distribute the r inside. So that gets me 2 pi integral 0 to 0.5 3r to the power 3 minus 6r to the power 4. Okay. Now when I take integration, integral of 3r cubed is 3r to the 4 over r minus integral of 6r to the power 5, 6r to the power 5 over 5, limits of integration 0 to 0.5. Well, 0 fetches me nothing. All I need to do is substitute 0.5. Presumably all my calculation is correct. This is the volume, 3 pi by 160 cube units. This particular example leads us to the following theorem. Volume of the solid obtained by rotating about the y-axis, region under the curve y equals fx from a to b is integral a to b 2 pi r fr dr. Well, we typically use x instead of r. So integral a to b 2 pi x fx dx. Okay. As long as a is less than b, they are both positive and so on and so forth. Example 2, set up an expression. So they are not asking you to evaluate. Simply set up an expression for the volume of the solid obtained by rotating the region between the curves y equals x, y equals 2x by 1 plus x cubed, around the line x equals negative 1. So it helps to draw a picture. Y equals x is this line, green line. That's y equals x. y equals 2x by 1 plus x cubed is this particular curve. So you want the region between these two curves, and you want to rotate this about the line x equals -1. So x equals -1 is to the left of y-axis. So you want to take this region, rotate it about this line. When you do that, you obtain a certain solid. So that's the region. Here is x equals -1 and you are rotating about it. So the solid goes around like this. So that's why you have one more picture of this here. All right. So you have rotated. So what happens here? This is 0, 0 and that's 1, 1. In other words, when x coordinate goes from 0 to 1, you get a cylinder. For each x, you get a cylinder of a certain thickness, dx, delta x. Height is this height. In other words, height corresponding to the upper curve minus height corresponding to the lower curve. So, what about the radius of the cylinder? Well, the radius of the cylinder is the x coordinate, but x coordinate is measured from 0. Radius of the cylinder has to be measured from -1. So 1 plus the x coordinate. All right. Now, doing this, solving this problem using concentric circles would require a lot more work because you would have to solve for x here. Okay. Instead, we are using the method of cylinders. For each x from 0 to 1, we obtain a thickened cylinder of radius 1 plus x. And height is upper height minus lower height. So that expression minus this expression. That's the height of your cylinder. Thickness is delta x. So 2 pi radius height. So that was the circumference height dx. You see, 2 pi radius height dx. Integral is from 0 to 1 because x coordinate, notice, starts from here and goes to 1. Okay, my curve goes from 0 until 1. All right. The rest is simply simplification, right? They have only asked us to set up the problem. So I will factor 1 plus x cubed. When I distribute 1 plus x, well, 1 plus x cancels here, 1 plus x multiplies x, and so on. This is simply the setup. Integral of the first quantity requires techniques we haven't learned so far. So we simply set up the volume. Volume is 2 pi integral 0 to 1 2x by 1 minus x plus x squared minus 1 plus x times x dx with respect to x. Okay. So I hope that gives us some idea. So this completes the theory for section 5.3. As always, I have closely followed the textbook, J. Stewart's textbook for calculus. Next videos will cover problems from web work. Until then, bye.